Hi everyone, in this video we're going to go through some more revision for equations. So they do start off relatively easy and then do get harder. Questions like question 1, obviously you can think about it in your head. So what number do you add to 5 to get to 12? But we're going to solve all of them algebraically just because you're going to get to more complicated equations where it's a bit too hard to do in your head or very time consuming. All right, so we've got t plus 5 equals 12. So what we want to do is the aim is always to get the letter on its own. So to do that, we need to take away 5 from both sides. All right, so I've got plus 5 and then the opposite of adding 5 is to subtract 5. So the reason we do that is so we can get rid of that. And then on the left-hand side, we're left with t. And then on the right-hand side, 12 minus 5 is 7. And you probably already knew that because you did it in your head, but remember we're going to do them algebraically. All right, question B, we think of a number that multiplied by 5 is going to give us 20, but algebraically we've got to do the opposite. So this is the same as 5 times w equals 20. So the opposite of multiplying is dividing. And you'll notice I write the divide as a fraction because in algebra we tend not to use a division sign or a multiplication sign, but there's nothing wrong if you use the division sign instead. All right, and then 20 divided by 5 is 4, so w equals 4. Remember, you can also check your answers just by substituting your answer back in. All right, question C, we've got x divided by 5 is equal to 2. So divided by 5 is equal to 2. So the opposite of dividing by 5 is multiplying by 5. All right, so we multiply both sides by 5. That cancels out. On the left-hand side, we're left with x, and then on the right-hand side, we're left with 10. So if you wanted to check it, 10 divided by 5 is equal to 2, and we're correct. We can move on. All right, now we've got t minus 12 equals 5. So doing the opposite. So if I'm subtracting 12, the opposite is to add 12. So the whole reason we do that is because negative 12 plus 12 is 0. So then we're just left with t on the left-hand side and 17 on the right-hand side. All right, question 2, find a solution to each of these. All right, so now we've got 2 steps. So we're multiplying a number by 3 and then adding 15 to get 27. Now, when we're doing that, we always get rid of the constant first. So the constant is the number on its own. So if we've got plus 15, we're going to have to subtract 15 from both sides. So we're left with 3a equals 27 minus 15, which is 12. And then we're left with 3 times a. So the opposite of multiplying by 3 is to divide by 3. So they disappear. Actually, they don't disappear. They're equal 1. I probably shouldn't say they disappear, but they cancel each other out. And then 12 divided by 3 is equal to 4. All right, next one. I'm going to just rewrite this so it's a little bit easier to see. So we've got 3 times g divided by 5 equals 6. Now, it's important that you follow the right steps. So even though we've got 3 times g, we do have to get rid of the divided by 5 first. So kind of think about when you're solving equations that whatever is closest to the letter is probably the strongest. So if you're going into battle, the strongest person's going to, protect the princess or the king or whatever. So everyone else is, out in the battlefield and you're going to get rid of them first. So the divided by 5, we want to multiply by 5 to get rid of that. So they disappear and then we're left with 3g equals 6 times 5, which is 30. Oh, excuse me. Oh, I thought another one was going to come on. And then the opposite of multiplying by 3 is to divide by 3. And then we're left with g equals 10. All right, question C, another 2-step equation. This time we've got 3 minus 8b equals negative 13. So our constant is 3. So remember, your negative sign is in front of a term. So this 3 is actually a plus 3. Excuse me. So to get rid of that plus 3, we need to subtract 3 from both sides. So then we're left with negative 8b equals negative 3 minus 3 is negative 16. Now we want to get rid of that negative 8, and it is multiplying the b, so the opposite of that is to divide, and we're dividing both sides by negative 8 because we want b on its own. All right, and then we've got a negative divided by a negative, so it's going to be positive. Our answer is going to be positive, and then 16 divided by 8 is 2. So this one's a little bit harder because of the order. All right, so just be conscious of that. All right, question D. This time we've got our unknown on the right-hand side, but you can still solve it the same way. If it helps, there's nothing wrong with switching sides. All right, like I've just written over there. Yeah, you can easily just do that if you don't want to deal with the unknown on the right-hand side, but I'm going to deal with it on the right-hand side. All right, remember we always want to get rid of our constant first, so we're going to subtract 9 from both sides. So negative 7 minus 9 is negative 16 equals 4p. And it's 4 times p, so the opposite of multiplying by 4 is to divide by 4. So negative 16 divided by 4 is negative 4 is equal to p. And we do tend to write the pronumeral first, so p equals negative 4. But if you wrote negative 4 equals p, still correct. All right, question E. We've got negative 4 equals negative t over 5. So we want to get rid of that 5. So I'm going to multiply both sides by 5. So they cancel out. So 5 times negative 4 is negative 20 equals negative t. Now, because both sides are negative, I can just make them both positive. Or I can say, all right, let's divide by negative 1. So that negative and the negative cancel out. And then negative 20 divided by negative 1 just becomes 20. And so t equals 20. All right, question 3. Seems not as difficult as the previous question. Or is it? I don't know. Okay, so we're getting rid of the constant first. So we subtract 5 from both sides. So then we're left with t over 2, or t divided by 2. 8 minus 5 is 3. And then we multiply both sides by 2. And we're left with t equals 6. All right, and question B. Now, often I've said get rid of your constant first, but this constant is a part of the numerator. So we can't get rid of that until we get rid of the denominator. So we get rid of the 2 first by multiplying both sides by 2 because it is divided by 2. Now, if you think about it in terms of going out to battle, all right, that getting rid of the denominator first. It's on its own, whereas the 3k minus 2 is on the numerator. Okay, so we've got 3k minus 2. 8 times 2 is 16. Now we've got a constant, so I'm going to add 2 to both sides because it's the opposite of subtracting 2. So 3k is equal to 18. And then we've got 3 times k, so the opposite of that is to divide by 3. So k is equal to 6. All right, now we've got a constant on its own, which is the minus 4. So the opposite of subtracting 4 is to add 4 to both sides. So they go, and we're left with 3f over 2 equals 24. Then we want to get rid of the divided by 2, so the opposite of dividing by 2 is to multiply by 2, so we're left with 3f equals 48, and we're not, are we? Oh yeah, we're going to get an exact value. So I was just thinking if it was going to be a fraction. All right, divide both sides by 3, so f is equal to, is it 16? Yes. All right, but remember you'll have, well, you can't go that high on your multiplication chart. So let's just quickly do it over here. How many times does 3 go into 4? Once, with 1 remainder. How many times does 3 go into 18? It's 6. All right, so you can get 16 that way. All right, question D. Again, we're getting rid of the constant, and that is -4. Remember, the sign is always out the front. So we're going to have, oops, there we go, 5c over 3. So -4 plus 4, they cancel each other out. And then we're going to multiply both sides by 3. Oh, big helicopter going overhead. And then 30 equals 5c, so 5 times c. So the opposite of multiplying by 5 is to divide. So 6 is equal to c, or we write c is equal to 6. All right, question 4, we've got some brackets. So remember, we're just expanding the bracket first. So 2 times m is 2m, and then 2 times -7 is -14. And then it's a simple 2-step equation to solve. So add 14 to both sides. So 2m equals 24, and then we're dividing both sides by 2. Now, I did show some people another way of doing these ones, so I'm going to do that just on the side here. Now, the pink way will work for any bracket. This way will only work if the number out the front of your bracket is a factor of the number on the right-hand side. So it is for this one, so I can just say, all right, let's divide both sides by 2. So we got left with m minus 7 equals 5, and then add 7 to both sides. Now, I would encourage most people to do it the pink way, but the blue way is a lot shorter, but maybe a little bit more confusing, and it won't work all the time. All right, question B, expanding your bracket first. So 5 times 4p is 20p. 5 times -1 is -5. All right, add 5 to both sides. And then we're going to divide both sides by 20. So p is equal to 2. All right, in question 5, we've got the unknown on both sides. Now, we want the unknown or the letter on one side, and you can shift it to either side. The thing is, depending on which way you shift, you're going to get a positive unknown or a negative unknown. So if you want to avoid negative numbers, it's always a good idea to get rid of the smaller one. So we've got 3t and 2t, so obviously 2t is smaller. So I'm going to subtract 2t from the right-hand side just to move it onto the left-hand side. So we've got 3t minus 2t is t. All right, and then we're just solving for t. So I'm going to get rid of that 2 on the left-hand side by subtracting 2 from both sides, and then -6 minus 2 is -8. All right, question B. We've got -5w equals w. So this is smaller if you think of it in terms of a number line. So I'm going to add 5w to both sides. So we're left with 11 equals 6w minus 7. And then getting rid of that minus 7. So, oops. Sorry. 7, not 8. 11 plus 7 is 18 equals 6w. So divide both sides by 6. They cancel out. So 3 equals w, or w is equal to 3. All right, and I think this is our last question, so probably as hard as it can be. Now, if you're all right with brackets, you're okay with this one. All right, it looks probably a lot harder than it is. So just think, okay, I've got the skills to do it, so I can. So the first thing we're going to do is expand the brackets on both sides. So we've got 3 times 2m, which is 6m. 3 times 3 is 9. And then don't forget this plus 1 on the end. And then on the right-hand side, we've got 16 plus 3 times 3, or 3 times 3m, I should say, is 9m, and 3 times -1 is -3. Then I'm just going to bring the like terms together. So these are like terms on the left side, and they're like terms on the right side. So we're going to have 6m plus 10 equals 13 plus 9m. Now we want to get the unknowns on the same side. So we've got 6m on the left and 9m on the right. So I'm going to get rid of the 6m by subtracting 6m from both sides. So they cancel, and then I'm left with 10 on the left and 13 plus 3m on the right. And then getting rid of the constant, so taking 13 away from both sides. So -3 equals 3m. And then last step is to divide by 3. So -3 over 3 is 1. Sorry, -1 equals m, or m equals -1. All right. Good luck, guys. Bye.